Progress. Have you ever wondered, even today, most of the shopkeepers and retailers are managing their stocks, finances, and sales on paper? What if they could predict their future sales, which will help in preventing stock out? To overcome these challenges, we, Team Fukre, have come up with DigiStore. DigiStore not only caters the needs of the shopkeepers, but also takes into considerations the need of the customer. So first I will demonstrate the working of the shopkeeper's side of the portal. It prompts me to log in. If I do not have an account, I can one. So I will quickly log into my account, which is sachit@gmail.com. I will enter my password. It will redirect me the dashboard page. Dash weekly sales analysis, and it also includes all the important news and updates. It has another page called profile page. The profile page has all the details of the person. It also has the options to edit the profile or to change the password. This profile page is connected to the database called Total Records, which consists of all the details of the person in a collection called Register. Next, we have a very important feature called predict sales. We have trained an ML model to predict the sales of an item on a particular day. It considers several factors, including festivals, seasons, weekly sales, and sales on the same day in the previous year. We use the light GBM model, which uses feature engineering and hyperparameter optimization and yields the least mean absolute error. So I will enter the product ID, say for example 3, and I will then enter the date for which I want to predict the sales for. So I have typed 4th April of 2023. I will click on the submit button and it will predict, and hence it will show 9.2336. Then we have a stock availability page, which consists of all the current stock in the shop. So I can enter the stock here. For example, the item ID is 13 and the name of the item is, say, pants, and quantity is 2, brand, cost price, selling price, and the type of action is add. So I can even date and update as per requirement. So it is also connected to the database called added items, which has collection register. Register consists of the documents inside this table, which is being shown here. Now I have another column called dues. Dues has two pages, collect and pay. Collect includes all the money that needs to be paid back to you. So it means that person one owes me an amount of 2,000. I can add people, I can delete people, and similarly, I can update all these records. It is connected to a database called finance, which has a table, which has a collection called collect payment. Then there is another page called pay. It consists of all your pending payments. So I can just add, for example, I have to give person one an amount of 1,000 rupees. So I will just add it and submit it. It gets added. It is in the collection called pay under the finance database. Next, I will just log out of this account and show you the customer side. For the customer side, I have logged in as Piyush. As you can see, there is a profile page which has all the options to edit the profile or to change the password or the settings. I have my orders, which consists of all the items which I have ordered. Then I have my cart. I can buy or remove the items added in the cart. For this, there is another database called customers, which includes all the information about the customers' past collections. So in total, there are 4 databases and 5 collections inside our project. Now, I will just log out from here and let's move to the tech stack. For the front end, we have used JavaScript, HTML, CSS, Python, and chart.js. For the back end, we have used Flask for the server. To create the ML model, we have used Python, specifically the Lite GVM model. We have created the database using MongoDB. And to establish the connection between the database and the server, we have used PyMongo. So let's just have a look at the code. So app.py here acts as a server. It is written in Python on the Flask framework. We have structured our code into the folders like templates. It contains all the HTML files, and static contains all the CSS, images, and JavaScript files. We have models which consist of all the models, and we have another folder which holds the .pkl file, which is the pickle file. We have trained the model and stored it as a .pkl file so that it can do the correct predictions without taking much time. Thank you. I hope you all enjoyed the presentation.